Hi everybody, today we are going to study about examples related to Newton-George formula for forward difference interpolation, or you may say that Newton forward difference interpolation formula. Okay, now the Newton difference formula for interpolation is here. For since y is equal to f of x, we have to calculate corresponding value of y, that is it is denoted by yg at given value of x as xg as follow. So the formula is yg is equal to y naught plus p into del y naught plus p into p minus 1 upon 2 factorial into del square y naught plus p into p minus 1 into p minus 2 upon 3 factorial del cube y naught plus, here it is in up at 4 term, it will be up to p minus 3 upon 4 factorial rest into del raised to 4 y naught and so on. Okay, where p is equal to xg minus x naught upon h. Okay, where xg is the given value and x naught is our first initial value and h is the difference in between two values of x. Okay, now we consider the example related to forward difference. In that, the data is given as follow. The following are the data from steam table. Here it is given as temperature in degree Celsius and pressure. It is data in between temperature and pressure, kgf per centimeter square. Okay, so for 140 degrees Celsius its pressure is 3.685 kgf per centimeter square. Next, for 150 degrees Celsius it is 4.854. For 160 it is 6.302. For 170 the pressure is 8.076, and for 180 10.225. Okay, this is the data given and we have to find the pressure for temperature of 142 degree Celsius. Okay, so first of all we have to check here the temperature 142. If we check the values of temperatures given 140, 150, 160, 170 and 180, the value 142 is a nearer to beginning one. Okay, where the data is given, the 142 is nearer to beginning value of the temperature. Okay, so we will use here forward difference table. If we have to find the value 172 or 178, so it will be nearer to ending value of the table, so we will use Newton backward formula. Okay, so here you have to also remember that when we have to use the forward forward interpolation formula and backward interpolation formula. Okay, since here we can write here, since the value to be interpolated, that means we have to calculate value 142, that is pressure of temperature of temperature 142 degrees Celsius lies at start of the given observation, starting of the table, start of given observation, that is near temperature 140 degree Celsius, And so we construct forward difference table. We construct forward difference table. And use Newton's forward interpolation formula. Okay, now here given data, first of all we will write the given data in the form of x0 and y0. Now here let us use the variables x and y for the terms temperature and pressure. Okay, now values of x, which implies that now we define temperature as x and pressure as y. So first value is defined by x0, which is also known as initial value or starting value, which is 140. x1 is 150, x2 is 160, x3 is 170, and x4 is 180. Okay, now here when we observe the values of x, so here the difference between each values is 10. That means x1 and x0, the difference between x1 and x0 is 10. 150 minus 140 is 10. x2 and x1, 160 minus 150 is 10. 170 minus 160 is 10. 180 minus 170 is 10. Also you have to remember that we use Newton's forward interpolation formula only when the difference it is at equidistant. Okay, the difference between each values of x is equal. Okay, next values of y, which is defined by y0, which is 3.685, y1 4.854, y2 6.302, y3 8.076, and y4 is equal to 10.225. Okay, so this data is given to us. Now also we have given value of x, that is xg. We are defining the given value of x as xg, which is 142 degree Celsius. Okay, and we have to find corresponding value of y. Find corresponding value of y, that is, or which is equal to yg, which is we have to find. Okay, now first in step 1 we will find step size. Step size means we have to find h. Okay, so for h it is a formula x1 minus x0. Okay, so x1 is 150 minus 140, which is equal to 10. Okay, so it is a difference is 10. Okay, in each values of x. Next step 2, calculate p. We have to calculate p, and formula for p is equal to xg minus x0 upon h. Okay, now xg minus x0 upon h, which is xg value we have to find, given value of x is 142 and initial value is 140 divided by 10. So our calculation will give 142 minus 140, 2 divided by 10, which is equal to 0.2. Okay, that means value of u is equal value of p is equal to 0.2. Now we have to prepare a forward difference table. Step 3, prepare forward difference table. Now for forward difference table, here values of x, after that you have to consider the values of y. Next there will be first difference, which is denoted by del y. Next second difference, del square, or you may write only del square. Next third difference is del cube, and if necessary, if we will go to the fourth difference. Okay, now values of x are 140, 150, 160, 170 and 180. Okay, these are the values of x. Next, values of y are at first value is 3.685, next value is 4.854, next it is 6.302, next it is 8.076, and last it is 10.225. Okay, so these are the values which we have to given of y. Next, first difference, here del means is our first difference, and we will find the value of del by subtracting the value of y1 from y0. Okay, that means you have to, here if you are using calculator, you have to subtract 4.854 minus 3.685. okay, and its total calculation will be in fraction, which is 1.169. okay, that means this both difference of this first two term will gives us del. Okay, and its value is 1.169. okay, now for forward difference, when you writing the first difference, the difference of first to this, you may write it in as in center of both. Okay, so first difference is here 1.169. okay, next it will be difference of these two, 6.302. here we have to find 6.302 minus 4.854, which will gives us, here it is a fractional value, and you have to click on this ESD button, so it can be in integer upon integer can be converted into decimal, which is 1.448. so here we get 1.448. next, third difference, you have to write in its center only, so that we have to, or you may, okay, we will write in a center values only. Now next value is 8.706 minus 6.302. so its calculation will gives us 1.774, and last difference is of this two value 10.225 minus 8.076, which is equal to 2.149. okay, so this is difference 2.149. okay, next, here we got the first difference, which is denoted by del. Next, second difference, we will take in similar manner, we have to subtract these two values, 1.448. so we will subtract now, so it will be 1.448 minus 1.169, which is equal to 0.279. okay, so here it is second difference, first value is 0.279. next, here value of this two 1.774 minus 1.448 will gives us 0.326. so here difference of these two is 0.326, and last in each row you will observe that one value will be is less there, okay, than the previous column. Okay, next it is a 2.149 minus 1.774, so which is equal to 0.375, which is 0.375. Okay, now we will take next difference, which is del cube, which is column of del cube. In that we want to find difference of these two. So in that you have to first 0.326 minus 0.279, which is equal to 0.047. Here first difference is 0.047. Okay, next difference in between these two, 0.375 minus 0.326, which is equal to 0.049. Here difference is 0.049, and last difference is 0. Now last difference will be in between these two, 0.049 and 0.047. 0.049 minus 0.047 is equal to, which is 2 into 10 raised to minus 3. Now here 2 into 10 raised to minus 3, we see in calculator in this term 2 into 10 raised to minus 3, which can be written as, here it is a value 2, okay, you have to write 2, and it is given that it is 10 raised to minus 3, which means that after point or from this number you have to take 2 zeros, okay, and after that you have to make a point, and after that 1 0. That means 2 raised to 10 by 10 raised to minus 3 can be written as 0.002. Okay, so these two values are equal. Okay, this is our forward difference table. Okay, and in this forward difference table we only required these first values. Okay, so we will require only these values only, and these values are, so here first value is y0, okay, and 1.16, this value of 1.169 is del y0, here it is del square y0, here it is del cube y0, and last value is del raised to 4 y0. Okay, so these values we are required in Newton's forward formula. Okay, so when you construct a forward difference table, in that after calculation we will require first value in each columns. Okay, so our formula is now for Newton's forward. Apply Newton's forward formula, forward interpolation formula. So yg is equal to y0 plus p del y0 plus, next term is p into p minus 1 upon 2 factorial del square y0 plus, next is p into p minus 1 into p minus 2 upon 3 factorial into del cube y0. Here in last column it is value 0.002 in del raised to 4. So we will write the formula up to del raised to 4 only. P into p minus 1 into p minus 2 into p minus 3 divided by 4 factorial into del raised to 4 y0. Okay, and it is not necessary to write next term because they are considered as 0. Okay, because difference of constant, it is a constant value and it is single value, so difference will be, next differences will be 0. Okay, so we have to consider values up to del raised to 4 y0. Now from this forward table y0 is 3.685 and it is also given value, plus value of p which we have calculated here, which is 0.2, So 0.2 into del y naught, our first value is 1.169. So 0.2 into 1.169, okay, plus p into p minus 1, which means 0.2 into 0.2 minus 1 divided by 2 factorial into del square y naught. So now del square y naught is 0.279, 0.279 plus p into p minus 1, which means 0.2 into 0.2 minus 1 into 0.2 minus 2 divided by 3 factorial into del cube y naught is 0.047, okay, and last value is plus 0.2 into 0.2 minus 1, 0.2 minus 2 into 0.2 minus 3 divided by 4 factorial into 0.002, okay. So we have written all values of p and del in the given formula, okay. Now we have to do the calculation of these values now, which is equal to 3.685 plus, now we will take a calculation of this term 0.2. Here it is given 0.2 into 0.2 into 1.169, which will equal to, here it is 0.2338. So first here we might write here 0.2338, okay, which is the first value of this calculation. Next plus, now here it is 0.2 into 0.2 minus 1. Now 0.2 into bracket 0.2 minus 1, and it is divided by 2 factorial, and value of 2 factorial is 2. So we will make first this calculation, this fractional calculation. After that we will multiply it by 0.279. So which is equal to, it is a something value minus 0.08, and we have to multiply this by 0.279, which is value of del square y naught, okay. So multiplied by 0.279, okay. So which will gives us, it is a fractional, you have to take, so it is minus 0.02232. Here it is value minus 0.02232, okay. After that now we have calculated this term 0.2 into 0.2 minus 1 into 0.279 upon 2 factorial, okay, and its calculation is 0.02232, okay. Now we will calculate this term, okay. So we will 0.2 into bracket 0.2 minus 1, which is our first bracket, here first bracket, and second bracket is 0.2 minus 2, okay, and it is divided by 3 factorial, value of 3 factorial, or you may write here 3 factorial also. Here it is a 3, and factorial notation is taken by using this shift and this x factorial notation, okay. So we will get a 3 factorial notation there, okay. Here it is in yellowish color, or it is a brown color, where and shift is also same color. You have to press first shift and after that x factorial, so which will gives us 0.048, and we have to multiply it by 0.047, which will equal to, which is now here again it is 10 raised to minus 3, so, and it is a positive term, okay. So plus, here positive it is, so first of all we will take 2 zeros after point, 2 zeros, 10 raised to minus 3, that means after point you have to take 2 zeros and write the total number 2256, and the last calculation we will here 0.2 into same process 0.2 into 0.2 minus 1 into 0.2 minus 2 into 0.2 minus 3 divided by 4 factorial. 4 factorial. Okay, so which is equal to, in fractional value, and we have to multiply it by 0.002. Okay, so its value is a minus value, and which is 0.10 raised to minus 4, which means we have to take 4 zeros, and after that we have to write the value 672. Okay, here 10 raised to minus 5, which means 40, and now we have to add or subtract these values. So we will get an answer in the form. So here 3.685, first value is 3.685, next it is plus 0.2338, here plus minus is minus 0.02232 plus 0.002256 minus 0.0000672. Okay, so our answer will be 3.8986688. Now here it is a 3.898, here it is a 6688, which means value after 6 it is greater than 5, so you may write here 3.8987. It is a value of yg. Okay, that means we have find value at xg is equal to 142 degrees Celsius, value of yg is equal to 3.8987 kgf per centimeter square, which is a pressure. Okay, so which is our required solution. Okay, so this is an process for solving the examples related to Newton's forward formula. And for backward also it is the same process. You have to prepare backward difference table, and here notations will be same, but process is same. And in backward we have to take the values at last of each column. Okay, we will see the example of backward in next lecture. Okay, for today we will stop here. Please see the example carefully and solve it by using calculator only. Okay, so thank you for today.